Okay lads, so during this video what I'm going to be doing is running through a worked example of our task 2 for our dynamic mechanisms question. So first of all, what we're going to do is read our question up here on the top left. So a circle A rolls clockwise along a line XY for 1/3 of a revolution. So this circle here rotates clockwise along our line XY for 1/3 of a revolution. Now if we also look here, the link QP is constrained to a slide through the fixed point S. So basically our linkage QP here is going through this point S. Now the distance stays the same, but this point X is fixed. Q is, okay, so let's say Q is a pin joined and attached to the circle. So Q stays constant on the circle itself. Draw the locus of point P and point Q for the movement. So as I'm looking at this, first of all, what we need to do first is find all our different positions of our point Q so that we can then plot the locus of the point P. So first of all, we'll start with plotting point Q. So if we break down the information, I can see here that it rotates 1/3 of a revolution, which a circle is 360 degrees. Divide that by 320 degrees. So all we need for it to do really is to roll, let's say if I divide this up into 12 segments, that we need it to roll a 4. So if I break this up into the first 4 segments that are going to hit as it rotates, my 60/30. Okay, so my first 4 segments, 1, 2, 3, 4. Okay, so what I'm going to do now is I'm going to label them. So I'm just going to call this R, R1, R2, R3, and R4. Okay, so each of these points here, as it rotates 1/3, will be hitting along the XY line. So what I can do now is I can take them heights with a compass, or then distances, sorry. So let's say from R to R1, mark it off here, and do that 4 times to get our 4 different segments as they hit. 1, 2, 3, 4. 1, 2, 3, 4. Lovely. Then also I can take a horizontal line, or basically a parallel line from the center here, which I'm going to call O. Point O here. The reason we're taking a parallel line from O to the XY line is because O will be always along this line that we're going to draw as it rotates along XY. Now what I can do is I can take vertical lines up from each section that I have here, straight up to hit that line. Now what I can do is basically indicate all the different points. So O1, O2, O3, and O4. If I do the same now with this section, so I'm just going to rename these with a different colour. We'll call these R1 as well, R2, R3, and R4. The reason that I'm calling these R and these R as well, because as this rotates, R1 will hit where the orange R1 is below here. Now what I can use to find basically where Q is at each of these points as the circle is rotating, I can use basically triangulation where I'm taking 2 distances. So for the first one, I'm going to want to know where R1, the distance from R1 to Q, and O to Q is when R1 is hitting below here. So let's say R1 to O. This distance, so if I go to R1 below here, draw an arc, distance R to Q, or O to Q. So my first point, I'm going to put that in red so it's nice and clear. And I'm going to call it Q1. Do the same thing again. Take this time from R2 to Q, that distance. Bring it to R2 here, draw another arc. Go O to Q. O2 to Q. There we go. I have my next point, which I'll call Q2. Then I'm going to go from R3 to O, like so. Take O to Q. Now I have my third point. 3. Then my last point, which is Q to R2 or R4. And then two lines intersect within two arcs is Q4. So what I can do now is I can draw my arc, which is the locus of my Q. As you can see there, so that's basically the path it follows as it rotates the circle. Now that we have Q and 4 different points as it rotates for 1/3 of a revolution, what I'm going to do now is get my distance from QP on my compass. Now I have a bit of a problem here. As you can see, my compass doesn't actually extend the full way. So what I'm going to do, instead of using the compass, I'm just going to take a measurement. So I'm going to take, it's 155 millimeters. So if I go from QO through S, 155 millimeters, I can call that point now P1. Do the same thing again for Q2 through S, 155. Like so. P2, Q3 through S, P3, same thing for Q4, Now what I can do is draw my arc. Now I can just exaggerate my curve a small bit so that it looks like that it's actually following like it should. Obviously, if we had more points in between here, it would give us more points to work off to help us generate that curve itself. But I'm just going to have to guesstimate here a small bit. Okay, so when you've that completed, that is the full question done. If you have any questions in relation to this question, I'm going to have a scanned copy of this that's going to be nice and clear, available on Solus as well. As well as that, if you're still stuck after that, send me an email or send me a picture of what you've done, and what I can do is have a quick look at it and see where you've gone wrong.